Okay, today we are going to cover section 6.6. We're going to be learning about what a fractional exponent is, also referred to as a rational exponent. So what you see pictured at the top of your notes page is basically demonstrating for you how to take a number, this would be what the b is, that has a fraction as an exponent, and rewriting it in a different way so that it looks like it is a radical. So I want to talk you through how to do this, and then we'll demonstrate it with a few examples here, because essentially what you're going to be asked to do is you're going to be asked to take problems that have fractional exponents and write them so they look like a radical, or vice versa. If it starts out looking like a radical, we are then going to rewrite it so that it looks like a variable raised to a fractional exponent. Okay, so the first thing that you'll notice here is the b is your base. So when you write this as a radical, that is still your base number underneath the radical symbol. Okay, how I often explain this in class is I want you to picture this fractional exponent as if it's a tower of blocks. Okay, and when you were a toddler and you built a tower of blocks, obviously you would try to make it as tall as you can. If you stood on this side and knocked the tower of blocks over, usually what happens is the block that's all the way at the top tends to fall the farthest over to the right, and the block that's at the bottom, it doesn't typically move very far. Okay, so if you could picture this fractional exponent as like a tower of, say, 2 blocks. Okay, the numerator is obviously the top block, the denominator would be the bottom block. And if you stood over here on the left side where the base variable is, and you knocked this fraction over so it fell over on its side, similar to knocking a tower of blocks over, the numerator, the tallest block, should be the one that's going to fall farther to the right. And so you can see where that numerator gets placed is it just becomes the exponent on the b that's underneath the radical. The denominator doesn't fall as far, and so the denominator value becomes the index of your root. Okay, and you can see this demonstrated right here. That's what this is saying. The denominator becomes your index. The numerator becomes the power of your radicand. Okay. All right, so let's go ahead and see if we can try to walk through a few examples of this. Basically, what we're asked to do here in the directions is if it's in radical form, we want to write it as a fractional exponent and vice versa. So here, this starts out as a fractional exponent. That means we are going to go ahead and write this in its equivalent radical form. So I'm going to go ahead and put a radical symbol. I'm going to place the x in the denominator. And again, if you just think of this tower of blocks falling over, the 1 is going to become the exponent on the x, and the 6, that's going to become the index. Okay, now technically speaking, you would not have to show this 1 here. You can, but if you don't put a 1 there, it would be assumed that that is an x to the first. Okay, let's try to go the other direction. Okay, in this next example, you can see this already looks like a radical. I'm just going to go ahead and draw a 1 in here as the exponent on the z. And so now what we're basically doing is it's like we are taking this tower of blocks that has fallen over and we're putting it back up right side. Okay, so z is my base variable. The exponent on the z will be a fraction. My index, my root, the 4, that's going to be the denominator. The exponent on the z, that's the 1, that'll be the numerator. So the answer would be z to the 1/4. Okay, let's just try a couple more here. Let's jump over here to example D. That one is very similar to what we just did here. So again, we're going to put this as a fractional exponent. The 8 should be the denominator. The 1 should be the numerator. Okay, and finally, we'll go ahead and do example E. We're going to write this one as a radical. So put our fraction bar with a D. Okay, remember whatever's in the numerator, that's going to become the exponent on the d, and whatever's in the denominator, the 4, that would become the index. So this answer would be the 4th root of d to the 7th. Okay, let's go ahead and try just a couple more examples. Instead of like these first few that we did here, the base was a variable. Okay, now you can see here the base is an actual number. Okay, what we want to do ultimately is we want to get the value of these expressions here, but I don't want you to just type them in as you see it here in the problem. Okay, if it starts out as a fractional exponent, then I would like you to first rewrite it as a radical, and then you can type it into the calculator. I don't want you to outright type this into the calculator. We're trying to practice how to write these in their opposing form. Okay. All right, so you can see in this first example, the fractional exponent is actually negative. Okay, and we've learned before that whether you make the numerator negative or the denominator negative, it technically doesn't matter. Typically best if you can avoid making the index the negative number. So I'm going to go ahead and leave the 4 as the positive and have this negative sign go with the numerator here. So I'm going to write this, put my radical symbol. I'm going to leave the 4 as my index, and this will be 81 to the negative first power. Now, in the previous lesson, we learned how to type into our calculator roots that are cubic or fourth or fifth. Anything higher than a cubic root, remember you start on your calculator by simply typing that index in. So you're just going to press the number 4 button, then you're going to press the math button. You're going to choose the operation that looks like this with a little x right there in the index, and then you're going to type in 81 to the first power. That's going to show you 0.33333 repeating, which means that answer is actually 1/3. Okay, we're going to try one more here. Okay, I'm going to go ahead and put my radical symbol. Again, I want to put the 5 as my index. I'm putting negative 3,125, and we're raising that to the negative first power. Okay, again, you're going to press a 5 on your calculator, then the math button. You're going to pick the option 5 that looks like this, and then you're going to type in negative 3,125 to the negative first power. That's going to show you negative 0.2. You can leave it like that, or you can express it as a fraction, negative 1/5. Okay? All right, let's go ahead and take a look here at these next couple examples here. These are probably the most difficult ones here on this particular notes page. Okay, this has what I call a nested radical. So we have this radical symbol, and then underneath that radical symbol is yet another radical symbol with something else underneath it. Okay, what you're doing with these problems is it is best if you can start all the way on the inside. So you want to start with the radical symbol that's on the inside. In this example, that would be this cubic root. I'm going to go ahead and just kind of highlight that. You want to focus on the inside radical symbol first. Basically, what this problem is saying is, if you were to manipulate and simplify the left side of this equation, it's going to simplify to something that's going to look like the right side of this equation, only they're not telling you what the exponent would be on the x plus 1. They want you to simplify the left side of the equation, and then they want you to report what would be that value for a, that missing exponent. Okay, so again, since we're going to temporarily ignore this outside radical, I'm just going to have you write that outside radical there, and we're going to focus on the part that I have highlighted. Now, remember, what's underneath the radical, that's the x plus 1. I want you to write this as a fractional exponent. So the 5 should be the numerator, the index, the 3, should be the denominator. Okay, now let's go ahead and take this square root symbol right here. Okay, now remember, I know that's a square root symbol because if I don't see the index, I know that has to be a 2. Okay, anytime we take the square root of something, let me give you an example over here to the side. If I have x to the 1/2 power, I know that is the same thing as the square root of x to the first. Okay, so essentially the square root of something is the same thing as raising it to the 1/2 power. Okay, so that means what we're going to do here is we're going to take this x plus 1 to the 5/3. Since we are taking the square root of that, I want you to enclose that in an extra set of parentheses. We're going to raise that to the 1/2 power. Okay, 1/2 power there. Okay, so we have x plus 1 to the 5/3, and then all of that is to the 1/2 power. These two exponents right here, 5/3 and 1/2, we're going to multiply those together. Numerators get multiplied, denominators get multiplied. That means I'm going to have x plus 1, and my new exponent will be the fraction 5/6. Okay, now, if you look at what we have here, this very much looks like what they said it was going to look like. You should have x plus 1, and there should be an exponent on that x plus 1. I'm going to go ahead and highlight that exponent. That is this 5/6, which is what the a is right here. So I'm going to report that the a is 5/6. Okay. Okay, we're going to try this with a few more examples so we can kind of get the hang of this. Okay, again, your initial focus should be on just this inside radical. So I'm going to leave the outside square root symbol there, and I'm going to rewrite this x plus 1 to the 2/4 power. Now, 2/4, I'm getting that from this 2 and this 4. Technically, that would reduce to a 1/2. You could reduce it now, or we could wait and do the reducing later. Okay, now I want you to look at this radical symbol right here. Okay, remember what we said, anytime you take the square root of something, that's raising it to the 1/2 power. So I already have x plus 1 to the, I'm going to go ahead and reduce that to 1/2. I'm now going to put that in another set of parentheses and raise it to the 1/2 power because of this square root symbol. Okay, I'm going to multiply these two fractions together, numerator times numerator, denominator times denominator, and I get x plus 1 to the 1/4 power. Okay, so again, my exponent right here, this 1/4, that's what that a would be. So I'm going to go ahead and report that a would have a value of 1/4. Okay, 1/4. We're going to try one more like this, and then we'll wrap up with just a few other examples here. All right, so once again, our focus is on the inside radical. We're going to go ahead and leave the outside square root symbol there. We're going to write this x plus 1 to the 4/5 power, and then we're going to deal with this radical symbol by taking x plus 1 to the 4/5 and closing that in parentheses and raising that to the 1/2 power. Okay, my two fractions that I have, 4/5 and 1/2, I'm multiplying those together. My new exponent is 4/10. I think 4/10, that would reduce. So I'm going to go ahead and reduce that to 2/5, and then 2/5 is what I want to use as what I'm going to report for what that exponent a should be, 2/5. Notice on all these problems, I did show some logical steps and a process. I don't want you to just memorize a pattern, show no supporting work, report what a is without showing any steps at all. You have to show some logical progression here to your thought process. Okay, let's go ahead and look at example 6. This is where we're basically just practicing how to simplify when you're multiplying two base variables and they have different exponents. It just so happens that these have fractional exponents. Okay, so for this first example, as long as we have the same base number, a and a, when you are multiplying two base values that have the same, what you're actually doing here with their exponents is you're going to add their exponents. Okay. Now, in order to add two fractions, they would have to have the same denominator, which these both do. So our common denominator is 7. We're then just going to add the two numerators to get a to the 6/7. Okay, notice it says here that we want to go ahead and write our answer in the opposite form that it was presented. So if it starts out as a fractional exponent, we want to write it as a radical. And if it starts out as a radical, we want to write it as a fractional exponent. So we're going to take it one step further here. Remember, knocking over that tower of blocks, the 6 would be the exponent on the a, the 7 would be the index. Okay, same thing here with this example. We both have the same base value p. I'm going to take these two fractions, I'm going to add them together. They have a common denominator already of 4. I'm going to add their numerators. I get 10. I'm going to go ahead and reduce that to 5/2 first. And then I'm going to write this as a radical. I could leave it just like this, the square root of p to the 5th. Also, if you put a 2 here in the index, that would be fine as well. Okay, now this is a different rule here in example 3. Example 3, we have a base number raised to a fractional exponent, and then that is enclosed in parentheses with another fractional exponent on the outside. This is the scenario where you are going to multiply the exponents together. Okay, now when you're multiplying exponents, the fractions don't have to have a common denominator at all. So we're going to multiply the two numerators together, get +5, the two denominators together, we get +6, and then we're going to write this as a radical. This would be the 6th root of b to the 5th power. Okay, now I have to be a little bit careful here with just the next couple examples. The entire radicand here on this example is the 3xy cubed. Now you got to be a little careful with this cubed symbol here. That cubed symbol is only pertaining to the y. It's not suggesting that the 3 and the y are also cubed. So technically, the 3xy cubed is all raised to the 1st power. So if I'm going to write this as a fractional exponent, I'm going to put 3xy cubed in parentheses. My denominator is my index, that's the 4, and my numerator is the 1. Okay, you don't want to confuse this 3 right here for what you would have put right there. Okay, same situation right here. Okay, I'm going to enclose this all in parentheses, put that to the first power. We have 64 z to the 6th, and I'm going to raise that to the 1/3 power. Okay. All right, our final example, and we really want to make sure that we're okay with this because this is going to pop up on several of the next few worksheets here, is we are wanting to simplify this expression. You can see this is a multiple choice question, and so basically we want to keep simplifying until our answer kind of collides with one of the possible options that we have here. Okay, now remember what we studied here in this particular section. We learned how to take something that's a radical and write it as a fractional exponent. So that's what we're going to do first. We're going to take this xy to the first power. So I'm going to put that in parentheses, xy. I'm going to write it as a fractional exponent to the 1/2 power because this is a square root. Okay, over here I've got my 25, same thing. This x right here is going to be written as x to the 1/2 power. Okay, I'm just going to do a quick glance. I don't see any of these answers yet looking like what I have here. So what I'm going to go ahead and do then next is I'm going to go ahead and I am going to distribute this 1/2 symbol in this first set of parentheses to the x and to the y. Okay, the reason I would want to do that is because that gets rid of the exponent that's around this xy. Okay, still, I'm not seeing that this answer matches any of these options, but I think in one step I could get it to match one of these 4 options if I think about factoring out a GCF. And so you want to ask yourself, do you see anything here in this first term, 5x to the 1/2, y to the 1/2, that also is showing up in the second term, 25x to the 1/2? Well, it feels like 5 and 25 both have a 5 that we could remove. It also looks like they both share the factor x to the 1/2. So I'm going to use 5x to the 1/2 as the GCF. Okay, remember when you're factoring this out, essentially what you're doing is you're dividing each of these terms by your GCF. So if we were to divide this first term by 5x to the 1/2, the only thing that we would have left behind would be this y to the 1/2. Okay, if we do that same thing here with our second term, divide this by 5x to the 1/2, the only thing that we leave behind is the 5. Okay, if I look closely at this answer right here, it looks exactly like what option D is. Okay, these problems that you're going to be asked to do on the next several worksheets, it's basically this same 3-step process that you will do. Okay, basically you're going to change the radicals into fractional exponents, distribute that fractional exponent, and pull a GCF out. Okay, I think that your assignment here is for you to complete worksheet 64-66.